This video here is for all you groundy guys that seem to think all power goes to ground. I'm going to try to dispel this myth because it is not true. Ground has really nothing to do with the AC circuit. It's simply a place for spikes, lightning discharge, static buildup, and on, a place to go, because the ground is a great big capacitor and it will accept stray charges. It's not really a lightning rod, but it does protect against the buildup prior to lightning striking. Now if you look right there, I have got a bare copper wire connected to what I call a ground rod. In this case, it's really a ground tank. This tank was sunk into the ground here as a way for me to be able to turn my water off and on. It's a big steel tank, plenty of contact with earth. I've used ground rods here too, and it comes out about the same. But anyway, it is connected to that because that's a pretty good ground source. It goes down about 6 feet. Environmental conditions, it has been raining for the last 2 days in this area. See, everything is wet around here. Now here you can see I have placed a meter with one of the leads on that steel tank. That's the red one, and the black one is on the copper ground wire. Let's look at the let's look at the ohms. Okay, we are reading 1/10 of 1 ohm. So there's good continuity to that underground tank. The next thing we're going to do is we're going to shove some power into this and see if we get a dead short. And I'll show you how that's set up. Now here you can see I have hooked up this ground wire to a lead, and let's see where the lead goes. Okay, here's my lead here coming to a breaker. I'm going to flip this breaker on and let's see what happens. Are you ready? Sput! No sput? Didn't do anything. What's going on? Do I not have what should be considered a dead short through this ground wire that is going down to the ground? And if you think that part of the circuit is the ground wire, you're wrong. It goes through neutral and back to the transformer, and that's where it clears faults. This will never, unless it is hooked to the neutral, which it is in the main panel, unless that ground wire is hooked to neutral, it will not clear faults, because ground does not do anything, especially this low voltage. This is only 120 volts. So it's not going to do much of anything. Just to double check, I went ahead and put a lead onto this, and the voltmeter's right back there. We're showing 120.8 volts. I'm going to the neutral bar on the panel. So between this lead here and the neutral panel is 120 volts. So there's 120 volts there. I shut it off, it goes away. Let's try another little trick here. Now here, I have a clamp meter. That should tell me if there's anything going through this circuit, shouldn't it? Well, there is something going through the circuit. 1.3 amps. Okay. Now, what does that tell me? If I was standing in a pool of water or had my hand on that ground thing, I would get a shock off of this, but it would not clear the fault. It would not open the breaker because there's too much resistance in the ground. Remember, this is a very wet day, and this is all I'm getting is 1.3 amps if I go just to ground. What everyone mixes up is the chassis ground and the earth ground that are in the panel. That does not lead to a direct short. The direct short leads to neutral. Now, if I put this wire straight over to neutral and kicked it on, pow, it would kick off right then. Probably ruin the breaker. This is what this is all about, guys. Think about it. Ground is very high resistance, and for these low voltages, it's not going to pass much through. So when you're thinking about ground and you're thinking about shorts and separation of chassis ground and neutral, think about what that ground is actually doing. It's a place for stray currents, lightning buildup, static electricity of all types, the odd little things that happen when motors start up, they'll shoot spikes back in the line. It will oftentimes take care of most of those. I mean, it's not perfect, but it does. That's why it's there. It's not for clearing shorts in the system. Okay, that's it on this one.